Hello, we are Team 6 Knots and we are proposing an idea on development of new ways of wastewater management in rural areas. This problem statement is given to us by the government of Rajasthan. Our project name is Advanced Smart Autonomous Sewage Treatment System or SAST for short. Our project design is largely focused on replacing the costly and harmful chemical methods in use today. Our unique proposition is that we are offering a low-cost, eco-friendly solution which encompasses a multi-level filtration approach. There are several features of our project worth noting. The use of oil skimmers for the removal of oil, addition of a novel 3-layer filter system, ozonization, and microwave irradiation to remove excess of ions and compounds. In our system, we have fit sensors along the way that will save the local municipality a lot of time, energy, and money by providing them with helpful data. Our design facilitates remote operation by communicating sensor data to a Raspberry Pi, which then transmits this data wirelessly over using the LoRa protocol. We have also decided to power our system using solar energy, which is plentiful in Rajasthan. This slide will be further explained in the upcoming slides. Coming to the question of what are we doing differently? 1. We are adopting an approach of non-chemical based solution. Unlike ordinary treatment plants that work round the clock, our machine need not be operated 24/7. We have a sewage water collection sump where the water is stored until the sump is full, which is then indicated by a water level sensor that is fit in the sump. When the water enters our system, we are removing the solid and floating obstacles in water by using the floaters that are located here, which guide the sewage into a disposal area. The sewage then passes through a mesh that is located over here that would remove any excess visible particles. After this, the water then enters an oil separation unit where oil and water are separated and the excess oil then would float on top like this. This excess oil is then skimmed off using an oil skimmer located here. Then the water enters the sump where, like mentioned earlier, the water would only be pumped out when the sump is full. Any sludge that is present in water here is then sent to a sludge treatment unit that is located here. Upon treatment, the biogas is separated from sludge and it is sent to the biogas collection unit that is present over here. Any byproducts from sludge that cannot be utilized further then go into the disposal area that is located over here. Once the sump water is pumped out, the sewage water then enters a 3-stage filtration unit, which encompasses of a mesh filter, a refined filter, and a polymer membrane that would remove any finer particles that are present in water. Any byproducts of this process are then removed in a waste collection unit that is located here. After filtration, the water then goes for the ozonization process. We decided to proceed with ozonization rather than chlorination to kill microorganisms, as it does not require the addition of any chemicals. Hence, it would not require further maintenance of adding chemicals. Here, oxygen is converted into ozone gas using an ozone generator. The byproducts are then filtered out and disposed. After ozonization, the water undergoes UV treatment, where UV rays are passed through water and any microorganisms further left in water are killed. The water then goes for microwave irradiation, where excess of ions and compounds are removed using microwaves. The treated water is then tested for quality using a water quality sensor, which measures predefined water quality parameters that we specify beforehand. The filter water is then stored in an overhead tank that is shown over here. These are our teammates. Akash Raj is our leader, and the team members include Ashwin, Siranjeevi, Kirutik, Chandika, and Anaga. Thank you.